Hi, this is Mrs. Milton. Welcome to Chapter 3 of Honors Algebra 2. Much of this chapter is going to be focused on function families and the different types there are, but that will come more in the second part of the chapter. Today is a super fun lesson called Interpreting Graphs. I think it's really important skill in the real world to have. So much data is given in our Twitter, TV, kind of social media society. So much data is given in terms of pictures, and if you can actually interpret and understand what these pictures of data are telling you, it helps you get to the truth of what the results are, of what the information is trying to say. So I think today's lesson has a lot of real world important things for you to think about. All right, looking at this picture here, you can see what looks like a container, maybe like a pop can or something like that. And it says if you filled the container at a constant rate over time, like imagine water going in, a graph of the water height would look pretty linear. As time goes by, the height of the water will rise at a steady rate. Just, we're assuming there's no holes in the container or anything like that. So this would represent a linear function where a graph, if something's increasing as a steady rate or decreasing at a steady rate, the graph would look like a line. So something like this, water pouring in, the sides go straight up. So you can just imagine the water being filled at this constant, steady rate until it gets to the top. Now these pictures show what graphs would look like for nonlinear functions, because in reality, not everything happens at a linear rate. You can imagine this first one, it says it increases super fast, but then the amount increases, it slows down over time. Maybe that would be a water vessel more like this. You can see the water would get really high super fast, and then over time it would slow down because it has more to fill. So that might be something that would represent this graph right here of a nonlinear function. From left to right, it's increasing because it's going up. This example right here is also increasing because left to right it's going up, but the increase starts slow and then changes to fast. So maybe that's more of a vase like this, where it takes a lot of time to get the water to build up, and then as it gets higher, it's able to rise higher and higher faster. These next two graphs are examples of decreasing nonlinear functions. From left to right it goes down, from left to right it goes down. You may recognize this example from chapter 1. It would be, we talked about hot cocoa a lot, where it comes out of the microwave really hot, it cools down slowly, and then eventually the temperature levels off. We'll talk more about that later. In class tomorrow, you are going to do an activity that helps you interpret graphs like this. I think this information and these sketches, as well as these linear ones, would be nice to have in your notes so you can refer back to it when you do tomorrow's activity. You don't have to write every last word down, but maybe a few of these key words would help your activity go much smoother. So I recommend pausing the video, make sure you have some good notes taken for 3-1 so far. All right, moving on to some vocabulary. I think you've heard all of this before, but the idea of a relation in mathematics is basically, it's just any relationship between two variables. It could be anything. The sun rises at 7 a.m. every day, then 7:01, then 7:02. The relationship between the time and when the sun rises would be considered a relation. You've heard maybe in algebra the term function used a lot, but maybe you haven't heard so much what it actually is. It's a special type of relation or relationship, but it's a little more specific. It's basically for every input, there is exactly at most one output. This one, I kind of like it here. It says if x is the independent variable, remember that's the variable that happens no matter what. Oftentimes it's time. A function pairs with at most one y with each x. I like to think of a definition of a function as for each input, be your x value or your independent variable, there is one output or one y value. So if you look at this picture here, if we look at this first one, we're in quadrant 1. Looks like we've got time and distance from something. We've got linear growth. And what happens is if I had a vertical line here, I'm not going to get into that yet. I'll save the vertical line for a little bit later. But basically, no matter what x value I'm looking at, you'd go up and you'd only find one y value on the line. The x value is over here, you'd go up, you'd see one y value. There wouldn't be two. So here, now it's talking about in this middle guy, a vertical line test. It says right here, no vertical line crosses the graph more than once. So if you look at this red line, as it hits the red parabola, it will only ever hit it at one spot. That confirms you have a function. So that confirms no matter where you put your x value, you'll only have one y value. So if you look at this third example, you have this parabola that's on its side. This would not be considered a function because it would fail the vertical line test. Do you see how you put a vertical line and whatever this x value is, it has a y value here and here. That vertical line, that x value has more than one y value, so that would not be considered a function. So I truly visually love that vertical line test. It's so easy to see. Oh, the vertical line only hits the picture or the graph once, it's a function. Hits it more than once, at any point, it's not a function. So if you tried these on a vertical line test to say, are these a function or not, I would get a few of these copied in your notes for sure. If you need to pause this for a second, that's fine. If you follow this red graph, look at this vertical line. It's only ever hitting the red graph once. So that means for every x value, there's only one y value. So this one is definitely yes, it's a function. So let's try this one. Easy to see. Oh, look it hits it twice. It's constantly almost hitting it twice. For example, here, when x is 2, y is both 2 and 4. So for that x value, there's more than one y value. So that is not considered a function. How about this guy, these discrete set of points? Well, that only hits once, once. So I would say absolutely yes, we have a function there. For each x value, there's at most one y. All right, now you look at these next guys down here, and they're, visually, it's harder to tell. It's like a little map here. And you'd read it as when x is 1, y is 1. So you have an ordered pair at 1, 1. Here, when x is 2, y is 3. So you have an ordered pair at 2, 3. What I personally like to do is really quick make a sketch. The x values are 1, 2, 3, and 4. The y values are 1, 2, 3, and 4. Let's plot these really fast. When x is 1, y is 1. When x is 2, y is 3. When x is 3, y is 4. And when x is 4, y is back down to 2. So when I have those points, whoops, then I can really kind of easily see that it passes the vertical line test. That vertical line only ever hits one point. So this one, you could definitely say yes is a function. This one is interesting. They all the x values go to 2. I kind of want to make a guess, but I'm a really visual learner and I want to know for sure. So if you look at it, when x is 1, y is 2. When x is 2, y is 2. When x is 3, y is 2. And when when x is 4, y is 2. That definitely would pass that vertical line test. The vertical line will only ever hit one
Elliot
point.
Friesen, please come to room 107. Elliot Friesen, please come to
Sorry
room
for all the
107.
interruptions, you guys. I apologize. Now what's happening with this last one, it takes a second to actually draw it out, and you know you'll get the right answer. When x is 1, y is 1. When x is 1, y is also 3. When x is 2, I've got nothing. When x is 3, y is 2, and y is also 4. You can see this is not going to be a function because when x is 1, it has 2 answers, and when x is 3, it has 2 answers. And remember, every x value can only have one y value. Here the x's have 2. That x has 2, that x has 2, so it's not going to work. All right, continuing on, I actually think I'm going to stop there and start a second video. So if you need a little break, now would be a good time to take it. Just make sure you watch the next video.